number theory. Okay, so today I'm just going to be going over some problems. The class curriculum for the next, I think it was like 10 classes, and also like expectations, rules, etc., etc. So I think everybody knows me probably from the presentation I gave a few hours, like an hour ago. 我叫 Jacqueline，现在在 Bloor Collegiate Institute，明年会上 McMaster University for Bachelor's of Health Sciences。从前教了9年级和10年级和12年级的数学，还有10年级的化学，10年级的物理，and 10年级 biology。现在contest experience 的话，I started doing contests in grade 8. The first one I did was Gauss. I managed to get the best in my school for that, which is kind of what made me really enjoy doing mathematics competitions. So every single year after that, all throughout my high school, I did every single contest that was offered at my school. So Pascal, Fermat, Kaylee, and also Canadian Senior Mathematics, Canadian Intermediate, and also Euclid in grade 11 and grade 12. I also did Canadian Biology Olympiad this year and Waterloo's Chem 13, which I was the best in my school for. And I also got a silver medal for Canadian Biology Olympiad. So yeah, I really liked enjoying doing these competitions because I thought they were a great way to expand your learning beyond the classroom, which is why I'm really excited to teach the Euclid class because I think it's like a great opportunity, especially if you're considering going to Waterloo as well. So the lesson schedule, there are going to be 10 classes. The first one is open, obviously. And every single topic that I want to cover is probably like very popular ones on the Euclid contest. So there is always a bit of like a format to the Euclid contest. For example, there's always some sort of geometry question. There's always some sort of logarithmic question. It's just a matter of which question that is, if it's number 5, if it's number 9, etc., etc. But the concepts still remain relatively the same year by year. So the most popular ones are the ones that I'm going to be covering. And you'll notice that in the beginning, it's pretty pretty simple. And then there's from classes 4 to 7 or 4 to 9, it'll be more heavy on geometry and so forth. So just keeping that in mind. Rules and expectations. So first of all, be respectful, participate. Please don't be afraid to ask questions. If I'm moving too fast, let me know. And I will be assigning homework after each class, but it's completely optional. And if you have any questions about how to solve them, we can take them up at the beginning of class before we move on. Or if I notice that there's a common trend in like things that students seem to be having difficulty with, then I will probably mention that at the beginning of class as well. So without further ado, I'll get started on number theory. So number theory, in very simplistic terms, is just the study of integers. Specifically, I want to be talking about divisibility because that's a popular topic on Euclid as well. So by definition, we say that an integer n is divisible by a different integer m if n is an integral multiple of m. So integral meaning like you can rewrite it in as some integer times another integer. So we can say that 15 is divisible by 3 because 15 is equivalent to 5 times 3. And the numbers which divide a given integer, we call them divisors. So divisibility rules is essentially looking at the characteristics of some numbers that are continuously divisible by others. For example, oftentimes in the beginning, they'll tell you that if the last digit of any number, doesn't matter how many digits they have, if the last one is 02468, then it'll be divisible by 2. So it's kind of building off of that. So for example, we're going to be looking at the integers 1 through 11 and their divisibility rules, just because after 12 and beyond, you can look at 12 to be 6 times 2 and then just refer to the divisibility rules of 2 and 6. So some key divisibility rules to point out. So 2, you need the units digit of n to be even. For 3, you need the sum of digits of n to be a multiple of 3. So you're going to add all the digits and see if that's multiple of 3. 4 is if the last 2 digits of n form an integer divisible by 4. And this comes from the fact that 25 times 4 is 100. So you just need to look at the last 2 digits, the 10s and the 1s, to figure out if your number is going to be divisible by 4. For 5, is pretty obvious. Your units digit has to be 0 or 5. 6, the divisibility rules for 6, you can break that down to just the divisibility rules for 2 and 3, just because 2 times 3 is 6. 7 doesn't really have a divisibility rule per se. It changes depending on who you ask. Some people say that there is none and others say that there are. The way I was taught is that, and I'll annotate this, is that if you have a 2-digit integer like a and d as so a is representing your tens digit and d is representing your ones, you can check the divisibility for this integer by seeing if a minus 2d is going to be divisible by 7. So that's one way to figure it out. 8, you have to check if the last 3 digits of n form an integer divisible by 8. This comes from the fact that 125 times 8 is 1,000. For 9, the sum of the digits of n has to be a multiple of 9. 10, you're checking if the units digit of n is 0. And 11 is if the alternating sum of the digits is divisible by 11. So keeping this in mind, things to note would be 3 is a popular one, 8 is also a popular one, and 11 are popular ones. So the star ones are ones that I've seen before on Euclid, and some of them are very obvious to remember, like 2 and 10 and 5, which is why they're generally not tested. But 3, 8, and 11 are ones that are commonly forgotten by students, and I've seen before on contests. So please be careful of those. All right, so we're gonna try out a problem. The first one is, and I'll read it out loud for everyone. The integer 541g 5072h6 is divisible by 72. And if g and h each represent a single digit, what pairs of values of g and h are possible? So the first step to any question is to figure out what they're asking you. And this is really common where students will figure out what g and h are, and then they won't write on their contest paper the pairs of values. And so because Euclid is a written contest, so every single question, or most of the questions, are evaluated on how well your solution is written, marks will still be taken off even if you know what values of g and h work. So it's important to make sure that you know you're looking for pairs of values. You can't just write the values of g and values of h that work. You need to show that you know which pairs work as well. So your first task is to determine the criteria needed to ensure divisibility by 8. Just because you can break up 72 as 9 times 8, which means that you need an integer that's both divisible by 9 and 8. And again, you can refer back to your prior knowledge about what those divisibility rules entail. So in order for this integer to be divisible by 8, we need the last 3 digits to be a number that is divisible by 8. You're just checking for the last bit, and that's really helpful too, because we can easily figure out what values of h are going to work, and then figure out which values of g those will correspond to. Also, another really good reason to starting out with the divisibility rules for 8 instead of 9 is just the fact that for the divisibility rules for 9 require the sum of all of the digits to be a number divisible by 9. And because you have 2 unknowns and only 1 equation, you can't really find a solution to that. There's going to be an infinite number. So that's your thinking behind that. All right, so next thing we're going to do is kind of trial and error. We're going to substitute every single value from 0 to 9 as a potential 1 for the value of h. And we're going to see if 202h6 is going to be divisible by 8. So you'll notice that if h is 1, h is 5, or h is 9, you're going to have a value that's divisible by 8, which means that your value for h can only be 1, 5, or 9. And that narrows down your possibilities for figuring out what values of g will work, because you now have successfully figured out what cases you're going to be looking at. You don't have to check them all. All right, so next thing to do is to check for divisibility or to ensure that the criteria needed is like successfully fulfilled for divisibility by 9. So we already know that the integer is going to be divisible by 8 because we know the choices for h, our values, are going to be 1, 5, and 9. So as the divisibility rules state, an integer is divisible by 9 if the sum of its digits is also an integer divisible by 9. So we're going to check for the first case, which is essentially when h is 1. When you have a 10-digit integer, we're going to like add all of their values together. So 5 plus 4 plus 1 plus 5 plus 0 plus 7 plus 2 plus 1 plus 6 and plus g. So that is going to give you 31 plus g, which has to be divisible by 9. And since we also know that g has to be some value between 0 and 9 inclusive, 31 plus g also needs to be a value between 31 and 40 inclusive, just because 31 plus 0 will give you 31 and 31 plus 9 will give you 40. And we're including those values as well. So between 31 and 40, the only integer divisible by 9 is 36. So therefore we know that 31 plus g is going to be 36, which gives us g equals 35. So that is our first pair of integers that work. And at this point in Euclid, what you probably want to do is just write that down, lest you forget, or you want to write it all down at the very end and make sure you don't forget. Okay, so we're going to do the same thing for our next case, which is basically when h is 5. So adding up all of your values together, you're going to get 35 plus g, which must be divisible by 9. And that is going to give you some value for 35 plus g is going to be some value between 35 and 44 inclusive. And so again, the only integer divisible by 9 between those two numbers is 36. So 35 plus g is going to be 36. That gives you g equals 1. And we have our second pair of potential values for g and h. The last thing is, our last case is going to be h equals 9. So you're going to have, again, adding up all your values, which is going to give you 39 plus g, which must be divisible by 9. And since g is between 0 and 9, 39 plus g must also be between 39 and 48 inclusive. And again, the only integer between those two values that is divisible by 9 is 45. So therefore, you know that g has to be 6. And so if you're writing all of this criteria down, Euclid will give you marks for showing each individual case, but you don't necessarily have to write down like the word values. You can just write down the equations and they'll give you full marks for that as well. And you'll also need to write down this final statement, which is basically, therefore, the possible pairs of values are h equals 1 and g equals 5, h equals 5 and g equals 1, h equals 9 and g equals 6. So only if you have to write down the sentence basically to show that you have all of your pairs. Otherwise, Euclid will take off marks even if you've actually found all of your numbers. So yeah, that's very important. Okay, so that's just a brief rundown of using divisibility rules for a question like this, which will probably be maybe like question 5, question 6. So make sure you get those as well. This next question, I'm gonna open up to the students that are participating in this class and give you a bit of time to maybe think about how you would go about tackling this problem, because it is a little bit on the verbose side. So I'll read it out for you guys. The question states, there are students in the math club at Scion Secondary School. When Mrs. Fryer tries to put the students into groups of 4, there's one group with fewer than 4 students, but all of the other groups are complete. When she tries to put the students in groups of 3, there are 3 more complete groups than there were with the groups of 4, and there's again exactly 1 group that is not complete. When she tries to put the students into groups of 2, there are 5 more complete groups than there were with groups of 3, and there's again exactly 1 group that is not complete. So the question is asking you, what is the sum of the digits of the integer equal to? By integer, and this expression is missing, but n squared minus 1, where n is the total number of students within Mrs. Fryer's class. So this question is a little bit on the long side. So I will give everyone 10 more seconds to read it before I reveal the answers. I will also be asking questions to you guys about what you think the first step of this problem should be and what you guys would do to solve it. So if any of you guys are listening, please feel free to unmute and tell me how you would approach this problem. So yeah. Okay, so first question, does anybody have any idea about how they would go about approaching this problem? Before I reveal the first way to solve this problem. And it's okay if you don't, I will just continue on. Okay, I'll keep going, but if anyone has anything to add, please feel free to. So the first method that I have is a little bit on the more trial and error side, in the sense that you're gonna have to like keep trying specific numbers, but the whole point of divisibility rules and the whole point of some of these methods that I've like just told you guys of is to make the most effective use of trial and error as a method. Okay, so the first question that you should always be asking yourself when you read a problem is why the problem is giving me this sort of information. And I find that extremely helpful, not only with questions that have to do with divisibility and number theory, but also and especially with geometry, when they give you certain proportions or certain angle measurements, and it is your job to ask yourself why they are giving this to me and then figure out where to go from there. So when you read this question, you should first ask yourself, what does knowing that there are incomplete groups of 2, 3, and 4 tell me about the number of students that there are? So, you know, because the question specifically states that when the teacher tries to put them in groups of 2, 3, or 4, there's always one group of incomplete students. So you should be asking yourself why this information is presented to you, because Euclid and any other math contest will not waste time giving you information you do not need. So what does this tell us? Well, it tells us that the number of students there are is not going to be a number that's divisible by 2, 3, or 4. And therefore, by definition, you can extrapolate this idea to successfully and to logically conclude that the number of students also cannot be divisible by 6, 8, or 12. 12 is not that helpful to you because 12 is also 6 times 2, but it's also a fact that's worthwhile knowing. So the numbers that so that is one method that you can use if you decide if this was a question that you came back to, this might be a method that you would try out. So if you have a little bit more time on your hands, you can try out, so n squared minus n, which would be 31 squared minus 31 gives you 930. And then you can say that the sum of the digits n squared minus n would be 9 plus 3, which is 12. So your actual answer is 12, but you have to figure out how many students there are. So again, read the question to make sure you know what they're asking, instead of just assuming that they're asking for the number of students and moving forward from there. So if you have a little bit more time, you can use algebra to solve this problem. So in this sense, you would represent, say, the number of complete groups of 2 by some variable, because you know that the number of complete groups of 2 is 5 more than the number of complete groups of 3. There are g minus 5 complete groups of 3. And again, you can use this fact to also write another expression or another equation for the number of students, n, which is either going to be 3g plus 1 or 3g plus 2. Again, the plus 1 or plus 2 comes from that incomplete group, but this time we don't know if that incomplete group only has 1 or 2 students, so we need to account for both of these base cases. So we have now 2 equations and 2 unknowns, which means that this system of equations is completely solvable. We are going to classify for 2 cases. The first is if 2g plus 1 is going to equal 3g plus 1. And the second is if 2g plus 1 is equal to 3g plus 2. So you're going to isolate for both values of g. So this is pretty similar by the fact that we know 3g. Okay, so essentially, if you isolate for these, you should get g minus 5. Oh, you have g minus 5 complete groups, and then you have plus 1. So you're gonna expand this to be 3g minus 15 plus 1. Or you could just recognize the fact that you have plus 1 on both sides and take that off. Then you have g equals 15, as you're going to move this minus 15 to the other side, and then this 2g to the other side as well. And the same thing goes over here. If you have 2g plus 1 equals 3 and bracket, start bracket, g minus 5 and bracket plus 2, then you have 2g plus 1 equals 3g minus 15 plus 2, and then that's going to give you 3g minus 13, and then you have g equals 14. So now that you have 2 values for g, you can figure out which one is going to work for our criteria in the number of groups of 4 that it needs to have. So if g equals 15, n is going to be 2 times 15 plus 1, which is 31. And if it's 14, you have n equals 14 times 2 plus 1, which is 29. So looking at the number of groups of 4, this has 30, you're going to have 7 groups of 4, and then you're going to have 1 incomplete group. Some numbers of 3, and number of groups of 2. So for this one, you would have, for 31 students, you have 15 complete groups of 2, and then you have 10 complete groups of 3. And if n is 29, you're going to also have 7 complete groups of 4. But for the number of groups of 3, you're only going to have 9. And for the complete groups of 2, you are only going to have 14. So if you, again, go back to the question, you'll realize that the difference in the number of groups of 3 and 2 has to be 5, and for 4 and 3, it has to be 3. So again, this one is the only, probable and like the correct answer for the number of students that you have. And then you can go back and say, okay, if I know what n is, then I need to find what n squared minus n is, sum those digits, and you will also again get 12. So it doesn't matter which solution you decide to do for Euclid, both of them work equally as fine, and you'll get correct marks. You'll get all marks no matter which one you choose. It's just dependent on how much time you have, so pacing, and also what you're most comfortable with. If you really didn't have any idea about how to solve this question, then chances are you're probably going to go with method number 1, because that's more logic, intuitive heavy. Whereas if you're more comfortable with algebra and working with numbers, then you will probably pick method number 2. So yeah. All right, so thank you everyone. And that's the end of my class.
Excellent. Yeah. Very great job you did. Euclid. Euclid, so Euclid give me a very deep impression. Yeah. Her structured teaching, and she gave us the alternative solutions, and show us one by one to spark the students' creativity. Now, thank you. Thank you, Jacqueline. I hope you guys can learn more from her in her class, Euclid class 1. So if you Jacqueline, really appreciate it. So do you have any questions for us? Hi guys, do you have any questions for us about the Jacqueline's class or about the other class at our school? Okay, Jacqueline, thank you. Yeah, you can quit from this session. Yeah, really appreciate your effort. Yeah, you did a very excellent job. Thank you. So 大家好，就是说Euclid 的这个 class 它的价钱是在这儿的。一班和二班价钱是一样的，2个班都报的话可以便宜100块钱。那么今天5点钟之前报名的话呢，可以享受这个 early bird。那么今天5点之后呢，就是只有这个 normal price 的。不知道大家关于这个 Euclid 的班有什么问题没有？让我 share 一下我的屏幕吧。